Okay, now we're going to be talking about graphing two variable absolute value inequalities. This is not um, going to be a big leap from what we've done because we've already graphed two variable absolute value equations in Unit 1. So when we talked about all those transformation rules, shifting left and right, shifting up and down, dilating, flipping, all of those things we applied to absolute value graphs in Unit 1. The only thing we're adding to it now is determining the type of line and the shading from the inequality sign. And that should be a review from when you just graphed linear inequalities. So a lot of this should seem familiar. So to do this, all we're going to do is graph the absolute value as we normally would. So if you can see here in my picture, what I did first was I just plotted my points. I got my points based on my transformation. So I shifted to the right 4 and up 5. Remember that horizontal transformations occur inside the absolute value and they occur opposite from the way they appear. So because it's a -4, I actually shifted to the right 4 to +4. And vertical transformations occur outside and are straightforward. Because there's no dilation, I just graph my parent function from there, which means a slope of up 1 and over 1 on either side. Once I've got my points plotted, I determine the type of line and the shading from the inequality symbol. So here's our key. I'd like you to make sure that you write this down very carefully. If your key is wrong, obviously you're going to get everything wrong. So anytime it's an or equal to, you're going to use a solid line, as we have in this case, because what that's saying is that the actual inequality symbol or graph itself is part of our equation. Um, y is less than or equal to this equation. So anything less than that would be below. So that's why I've shaded underneath my graph. That would be less than or equal to my graph. In the next example, we have y is greater than negative absolute value of x plus 2 minus 3. Again, that horizontal shift is opposite, so I shift to the left 2. The vertical shift is straightforward, so I shift it down 3. And the negative gives a vertical flip, so I'm upside down, and I graph my parent function from there. The inequality symbol in this case is greater than, which means a dashed line. My solution does not include the actual absolute value graph itself, but it does include everything bigger than that, so I shade everything above it. Okay, in example 2, we're going to do something a little bit different. Now they're giving us the graph and we have to come up with the equation. So based on the graph, we want to essentially just figure out the information that we generally know in step 1 and step 2. We want to figure out, is the shading above or below? In this case, it's above the graph. We want to figure out if the line is solid or dashed. I know it's a little bit hard to tell, but that's a dashed line. So that right there is enough to give us our inequality symbol. Above means greater, dashed means not equal to, so just a regular greater than sign. And then we just want to take a look at our transformation. So in this case, our vertex is shifted to the right 3, sorry, and up 2. So that's where I came up with that. That's going to give me my transformation of -3 and +2, and there is no dilation. The slope has remained the same as the parent function. We're done. Okay, so I want you guys to pause the video here and see if you can figure out the U try number 2, and unpause it when you're done and see if you're right. Okay, so hopefully you got y is less than or equal to the absolute value of x plus 4 minus 3. We shifted to the left 4, so that would be a +4 in our equation, or inequality, I should say. We shifted down 3, that would be a -3. Our line is solid, and we've shaded below, which means a less than or equal to. Now you're going to get some practice to try. Good luck. I'll see you guys on Monday.